Good afternoon, CIIS EEG students. So for the next installment here for our course, this video, I want to show you how to clean data, and I specifically wanted to use data on which I did a specific experiment, which is where we are moving next. So first of all last week you needed to be practicing, and I know that one or two or three of you have been trying to clean it and so on, and that's great. Now I'm going to show you. But specifically, you needed to also be able to just save the data and access it. That's step one. Save it, access it. And if you did that 5 or 10 times, no matter what it looked like, that's great. The main thing was to save it and be able to access it. Now, the next step is once you access it, what does it look like and how do we clean it? But that has to be relevant to a specific experiment. So that's what we're going to do right now. Now, I chose an experiment. Again, keep it very, very simple. Yesterday, and what I did was use the Muse 2 headband, and I and then in record mode using MindMonitor and the Muse headband, I relaxed for 60 seconds and then counted backwards from 100 by 3 until I got to the end and then stopped. So essentially I ended up with about a 2-minute and 10-second data recording in continuous mode. Given that, I got now the data that you see here on your screen. So it goes, this is the raw data just as it came off. Now you'll notice here I don't have many blanks. And the reason I don't have many blanks is because I was extremely deliberate and diligent about making certain that all of my contacts were steady and constant. Because if you don't have steady, constant contacts, your data is going to be corrupted and in some cases, many cases, in fact, unusable. But in this case, for that approximately 2-minute and 10-second recording I did on continuous mode now, I accessed it. I saved the data like I showed you last week. I saved it to a cloud file or to a server, anywhere you want to go, and it saves as a .csv file. So it's a comma delimited Excel file essentially. Import that, and this is what I've got right here. So I imported that file. I found that file, saved it, and now I brought it over to my workstation right here, and this is what I've got in Excel. You can see here, though, it's still a CSV file there, and it's named Muse Monitor. There's the date yesterday, the time I did it, and it's still a .csv file. So I've yet to, in this mode, so far relative to this file, I've yet to do anything with it. Now, the first thing I want to see, well, how much of it is there? So if you scroll all the way down for 2 minutes and 10 seconds on a continuous basis, I have almost 35,000 lines of data, going from there all the way up, 35,000 lines of data in 2 minutes and 10 seconds. So something was happening then. 2 minutes and 10 seconds. Now, again, if you notice here, I have going across, I have very few spaces, and that's what you want to aim for. And the only way you're going to get that is to make certain that you have, during the entire time that you are recording, constant contact with your frontal and temporal lobes. Okay, given that, and looking at this data is exactly the way it is right now, just coming over, this is the raw data file that I looked at. The first thing I like to do is highlight all of the columns, and then in Excel, if you just double click at anywhere in between the columns, what it does is that it will automatically expand all the columns for you so that there's no overlap of the columns. And so in doing that, I can see that I've got the timestamp there, which is at this point somewhat useless data. I eliminate that, and I'll show you how that's how we do all that stuff later. And then when you scroll over here, there's all kinds of stuff that I don't need right now. We don't need right now in my experiment, this experiment. So I don't need any of this accelerometer stuff or headband or any of the other indicators saying that where there was or was not contact. The ones and zeros just mean contact or no contact. So right from this point on, we are interested in basically four contacts. Those are temporal lobe left and right, frontal lobe left and right. That's what we got. The rest of this stuff, like accelerometer, all of this jazz, you can just go over there and just delete it like that, and it's gone. Now I've developed this file much further than what you see now. I just simply wanted to show you here what I've got so far. In fact, I want to keep it, so I'm not even going to save it with that deletion. But instead, I want to show you where I went from here. So you can delete this, delete various things that you don't need. Timestamp, of course, would be one of them, unless you're interested in, if you know exactly when you started and exactly when you then entered your experimental mode, then of course the timestamp might be useful as well. But that's also in MindMonitor. You can use those little test point indicators to tell you exactly when you entered into another experimental condition. Today, my experimental condition was sitting, eyes closed, relaxed for 1 minute. Then at the end of the minute, I then opened my eyes and started counting backwards from 100 by 3. Given that, I want to know two things. Here's my experimental hypotheses. 1, in relaxing and then going into a count by 3 backwards from 100, was there any shift in the proportional power density from left to right or right to left? So that's just generally one thing I'm looking for. And then secondly, was there also a shift in, so we're going left to right, right to left hemisphere, A. B, is there a corresponding shift in the range of EEG spectrum or frequency utilized? So the common wisdom tells us that when you are doing something like counting or anything that requires more concentration, which counting by 3 backwards does require a bit of concentration, you get a decrease in alpha and an increase in higher frequencies, beta and gamma. Now, I'm just looking in this experiment, I decided to just look at alpha and beta and to eliminate theta and delta and gamma. So I'm not even going to look at those yet. Those I'm interested in this experiment only in alpha and beta and left and right. So I'm going to compare the two in both conditions. Okay, given that now, and given this, so here's just the basic file. And if I wanted to save this as an Excel file, in fact, I want to go back and get rid of and put my other stuff back here because I don't want to lose that for now. I just may need it. You know, you want to keep your options open. So there's the raw file right now, and I'm just going to go ahead and save this the way it is. In fact, I don't want to save it. In fact, you know what I'm going to do? I'm going to keep this as an SCV file. But if you want to save it as an Excel file, and you need to eventually, you just go save as Excel, and then you just save it as an XLSX file. And of course, you can change the name of the or label of the file as well. I'm just going to get out of this right now. and go to my next file. So I did some work on that file, that original file, and here's what I came up with. So here you can see I've got it in Excel. I created, I got rid of only everything except alpha for test point 10, beta test point 9, beta frontal, not test point, I'm sorry, temporal, beta frontal, beta frontal, and beta temporal. Then you see here also you've got gamma, gamma, gamma. So in this, I started out here. And in fact, this file, which is so if you look down here, I've got in here, I had to make multiple worksheets in the same file. This says relax, eyes closed. So I wanted to label this now. This is all condition, relaxed, eyes closed. And notice in here now that I also went down on the original file to where the condition ended and the other began. And so I remember there was 35,000 on the original file. So what I did was I went down in the original file and cut everything below that and pasted that into condition 2. Or in other words, my eyes are open and I'm counting. Condition 1, I wanted to isolate. So here's relax, eyes closed. We need to look at this in a step-by-step manner. You can't do this all at once, step-by-step manner. So the first step is get all the data relevant for the first condition. Then get all the data relevant for the second condition. So what's the second condition now? The second condition is I was counting. And here's all the data from that too. And it goes down to 17,476. Okay, so now we've got two sets of data, two sets of data. One when I was relaxed, one when I was counting back from 3, those two sets. But that all came from the single file that you saved and accessed and cleaned. Now, I didn't have to do much cleaning per se on that. The empty rows, let's say, for example, you come up with an empty row. Well, this is where timestamp might be useful. If the empty row or rows persist for too long, then your data is corrupted. You might as well just do it again. Anything else in there, like if you're getting strange characters or if you're getting zeros or stuff like that, then something's wrong. It isn't the data, it's how you're recording it. So make sure you're going back and you're recording it correctly. So I've got now my two data, my two conditions: relaxed, eyes closed, count back from 100 by 3. And I don't know if you can see that or not. Let me make this a little bigger. So here you've got relax, eyes closed, count back from 100 by 3. And now let's move to the next step. Next step is relax, alpha, beta. So now what I did here, I went back into both of these and I got rid of the timestamp. I got rid of all of the data. So delta you don't need. I'm going to take that out, that out, that out, that out, that out. I'm not interested in data and theta for now, for right now, for this experiment. Useless to me. So I just go through here, right like that, and eliminate them. Just go delete. Now they're gone. Then I go into, and so I've got here alpha, 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 beta, 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 beta. Gamma I'm not interested in. Get rid of the gamma. Also, for now, let's get rid of all the raw. You can do some things with the raw EEG, but for the time being, you can't. So let's get rid of that too. And now I've got here, basically, what I've got now is all my alpha for temporal, frontal, left and right, beta, temporal, frontal, left and right. Now the odd numbers So for temporal 9, alpha temporal 9, that's the left side, and frontal 7, that's the left side. Or in other words, the way it's set up, the way the manufacturer has it set up, the odd numbers are your left hemisphere, and the even number your right hemisphere. So alpha temporal 9, that's left. Alpha frontal 7, that's left also. Alpha frontal 8, that's right. Alpha frontal, temporal 10, that's right temporal, and so on. So you get the idea. So that's left, left, right, right, left, left, right, right. So okay, I'm going to put all that stuff that I took out of here back, because I just wanted to show you what I did to go to the next step. So now I am going to put that stuff back because I don't want it gone. And now I'm going to go to next. So now in going to that, I ended up now with this file. In pulling out and selecting exactly what I needed to do, I pulled out here. I've got alpha left, as you can see how I've got this labeled. Alpha left. Here's alpha TP9. So that's temporal, alpha temporal left, alpha frontal left. Here's alpha right now. So this is alpha frontal right, temporal right. So let me repeat that. So left side, alpha temporal left, alpha frontal left. And here's alpha right, alpha frontal right, temporal right. Then beta, same thing. And you still, and this now is in the relaxed condition. So all of this data, if you go back all the way back down here, that's in the relaxed condition. Now you have to do the same thing for the condition 2, or in other words, the counting condition. So then you take your data and you clean that or separate it out so you get your lefts and your rights. And again now, what we're looking at is not only cleaning, but cleaning moves toward configuring your data so that you can move it into an analysis, which is what I've done here. So I've gone to this step, the whole thing, and then in that, once you decide your experimental condition, and again, keep it simple. That's why I ask you for today to send in some ideas for an experiment using your Muse. So we can't do some extremely complex stuff, but we can do some basic experiments that make sense. And I really like the results from this experiment. As a little full disclosure, the results came out well, or at least as expected. So anyway, now I've got my basic experimental condition. Now, again, the analysis part of this course is not really part of the course. We're not really teaching you to analyze anything, but simply to gather your data. And then once you gather the data, well, what do you do with it? Well, there's some basic things you can do with it. You could use Excel to do some basic experimentation, given that you know your way around Excel. But the analytical and statistical capabilities of Excel are limited. So let's first, though, just think about cleaning, configuring, and then setting it up so that you can do an experiment. And also, you can send your data, last but not least, and this is something that I certainly would encourage you to do if all else fails, If you have a good data set, send it to me. If you set it up and configured it properly, send it to me and I'll analyze it in SPSS for you. So I made yet one more worksheet here, and this is called SPSS Ready. So in SPSS Ready now, again, this is an Excel file. I've got in this last worksheet the alphas right there. So so these are the variables I'm interested in. Alpha temporal left, alpha frontal left, alpha frontal right, and alpha temporal right, and beta temporal left, beta frontal left, and beta frontal right, and beta temporal right. Note here now I added yet one more variable that I created, because when I combined these two, that is, when I combined relax with count, I had to add the count here down at the bottom. So I just took that, then I grabbed this, copied all the data set, went to the very bottom of the relax data set, and pasted in this, so it's a then it becomes a continuous data set again. Now I end up again with all 35,000 rows of data. I'll show you here. So this is the SPSS Ready file, and so here's condition 1 right there, and then we go down, and there's condition 2. And condition 2 starts, let's see, a lot of numbers. Should start, so yeah, there it is. So condition 2, I started right there. So then condition 2 goes down. Condition 2 is counting. So condition 1, condition 2, and they are separated. So in other words, I needed to add the independent variable to this study. What is that? The condition. Relaxed, eyes closed, eyes open, counting backward from 100 by threes. So here's our cleaned experimental data for this particular experiment right here. Now, because I did it continuously, we ended up with a lot of lines of data. And fortunately, SPSS will handle the job, or Excel for that matter. But it was continuous. And remember that if you can also MindMonitor allows you to sample your brainwaves at rates other than continuously. And so that would be the next experiment. In fact, that I'm going to do is look at the difference between the two. So given that, I've got this. Now I'm going to then take this data, this right here, and I'm going to import that into SPSS. I've already done it. So now I'm just going to bring the file over and show you. So here's my SPSS file right here. This is the whole data set with my variables up here, as you can see. So you can see I should have here 8 variables. 1, 2, 3, 4, 5, 6, 7, 8, and then of course the independent variable, the condition. So I've got 8 dependent variables and 1 independent variable here under SPSS. And the results are very nice. When I conducted the experiment here, and the first thing I did was I conducted what is called an ANOVA, just a one-way ANOVA, because I wanted to look at the difference between condition 1 and condition 2. So here you can see I did a one-way ANOVA right there. I don't know if you can read that, and I can't blow up or magnify SPSS. So I hope you can read it. It says one way, and there's the variables right there, all the dependent variables by condition. If I compare the two conditions, left and right, across all of these dependent variables, I get results that are absolutely outstanding. Now, I am cautious about this outstanding result. Although it looks fantastic, and I'll even show it to you graphically, I'm cautious about it because my N, that is group size, the number of, of, um, of data lines, very large. And so with extremely large group sizes, or N, you can demonstrate a lot of significant results. So statistically, having huge group sizes, you can see tiny little changes that you can't otherwise. That's called a small effect size. And the small effect size, of course, is useful in some cases and not useful in other cases. You just have to be careful as to where you see it. So in this case, we're looking at very small effect sizes. And effect size is like the resolution on a monitor. If you have a picture, let's say a graphic, and you can't zoom in very far on it before it starts getting fuzzy and grainy looking, that's because the resolution basically has a very large effect size. If there's a very small effect size, then you can zoom in and see very small differences. So metaphorically, that would be about what it is. But you can see here significance 0, 0, 0, which means wonderful. It means that it is highly unlikely that these results would come about by chance or random occurrence. So this, and notice it says significance, means significance, 0.000, means that the probability of each one of those occurring randomly is at this point, then it doesn't take the decimals out any further. So it is at least 1 in 10,000th of a chance that it could have been a random occurrence. Looking at all of these like that, it is highly unlikely that this was just a random occurrence. I did the descriptives here. I'm not going to go into that right now. Here's a further analysis of it. But what I did do is what's called a means plot. And the means plot here is this. So here's on the horizontal axis, you see condition 1, condition 2. And on the vertical axis, you can see mean of alpha on the left temporal lobe. So mean of alpha, TP9, that is the left temporal lobe of your Muse headband. And we see here on condition 1, the prevalence of alpha dropped from here to there. And here we also see on the frontal lobe, the mean of alpha from condition 1 to condition 2 also dropped what appears to be significant. On the mean of alpha on the frontal, mean of alpha on the right also decreased, and the mean of alpha on the right temporal lobe also decreased. Up here, we're seeing on condition 2 now, the mean of delta on the left, beta, I'm sorry, the mean of beta on the left frontal lobe, boom, that went up. Beta going from here to here on the right dropped, on the right temporal lobe dropped. So amazing stuff, good stuff. We're not going to go into this analysis so much right now, as I want to show you just how to get to this point and then what we can do thereafter. In almost all conditions, though, once we have some data, we need to have some way of analyzing it. Your first route would be Excel. Your second route of analysis would be SPSS. Then beyond that, we go into even more complex routes of analysis, which would be like using MATLAB. Now, MATLAB is something that a lot of the neurocognitive scientists are using today. in that it not only gives you a numerical analysis, but it also projects the activity. You can use MATLAB to project that activity in 3 dimensions and look at changes also in real time. So this is where I want to stop right now. We've looked at SPSS, and we've looked at, let me get the Excel file back here, at how you get over there. But this, as you can see, to make that basic simple experiment, you need to make sure you have a very good raw file that you can access. Once you access it, then you need to clean it based upon your experimental condition and hypothesis. And again, keep it simple. I did the relaxing, and then next is counting backward by 3. You could do almost anything. You could, as long as you have, for now, just 2 conditions. Experiment and have a good time.